Next is question number 71, which says that the value of 1 square minus 3 square plus 5 square minus 7 square plus 9 square and so on up till minus 31 square is equal to. Now here if we take two terms at a time, then it will be equal to applying a square minus b square equal to a plus b into a minus b. So 1 square minus 3 square will be equal to 1 plus 3 into 1 minus 3, that will give me minus 2, plus here we have 5 plus 7 into 5 minus 7, that can be written as minus 2. Again in the next term we have 9 plus 11 into minus 2 and so on up till 29 plus 31 into minus 2. Now here if I take minus 2 common, so we get the series 1 plus 3 plus 5 plus 7 and so on up till 31. Now this is an AP, so its sum can be found out very easily. So it is equal to n by 2, as the number of terms are 16, so the sum will be equal to n by 2 into first term plus last term, that is equal to minus 16 into 32, that is equal to minus 512. That is the correct answer is option number 1, that is minus 512. Next, let's move on to the question number 72, which says that if pi by 2 plus cos inverse 8x upon 1 plus 16x square is equal to 2 times tan inverse 4x, then the set of exhaustive values of x is. A very simple question from inverse trigonometry where we just have to use its properties. Right? We know that cos inverse theta plus sin inverse theta is equal to pi by 2. So let us firstly use it. So it will give me pi by 2 plus pi by 2 minus sin inverse 8x upon 1 plus 16x square is equal to 2 times tan inverse 4x. That is, from here we get that pi minus 2 times tan inverse 4x is equal to sin inverse 8x upon 1 plus 16x square. Now we know that 2 into tan inverse x is equal to pi minus sin inverse 2x upon 1 plus x square when x is greater than or equal to 1. So we will use this property here in this question. So this will be true when 4x is greater than or equal to 1. So we can say that x is greater than or equal to 1 by 4. That is, x belongs from 1 by 4 closed up till infinity. So the correct answer will be option number 4. Next is question number 73, which says that consider a point A, B, C, which are given as vertices of a triangle, the coordinates of a point P such that triangle PBC is an equilateral triangle may be. Let us draw a triangle here, that is point A 1, 2, point B that is minus 6, minus 5, and point C that is 5, minus 2. Now here we have, let's say, a point P and this is an equilateral triangle PBC, right? Let us say the coordinates are x1, y1. So let us drop a perpendicular from P on BC, which will be, let us say, PD, where D will be the midpoint of BC, right? Because it is an equilateral triangle. Now let us firstly find the slope of BC. That will be equal to minus 2 minus minus 5, that is 3, upon 5 minus minus 6, that is 11. Now we have slope of BC, so we can say that slope of PD will be equal to minus 1 upon slope of BC, that is minus 11 upon 3. Let us say this is equal to tan theta. Now let us find the value of length BC. That will be equal to under root minus 2 minus minus 5 whole square, that is 9, plus 5 minus minus 6 whole square, that is 121. So that is equal to under root of 130. So from here we can say that BD will be equal to under root 130 upon 2. Now we have BD and we know that this angle is 60 degrees because it is an equilateral triangle. So we can say that tan 60 degrees will be equal to PD upon BD. That is root 130 upon 2. So from here we get that PD is equal to tan 60 is root 3 under root 390 upon 2. This is the length of PD, right? And we know the coordinates of D also because it is the midpoint. So it will be minus x plus 5 upon 2, that is minus 1 by 2, and minus 5 minus 2 upon 2, that is minus 7 upon 2. Now we can find the coordinates of P as coordinate of D, that is minus 1 by 2, plus R, that is the distance PD, that is equal to root 390 upon 2 into cos theta. We have the value of tan theta from here. So from here we find the value of cos theta and sin theta. So cos theta will be equal to minus 3 upon under root 130 and sin theta will be equal to 11 upon root 130. Now substituting here we will get minus 3 upon under root 130 comma y coordinate will be minus 7 by 2 plus r, that is PD, root 390 by 2 into 11 upon under root 130. So solving this we will get point P as minus 1 minus 3 root 3 upon 2 comma minus 7 plus 11 root 3 upon 2. That is option number 2 is the correct answer. Now let's move on to the next question, that is question number 74, which says that the condition for two circles to cut each other orthogonally if they pass through the points 0, a and 0, minus a and touch the line y equal to 2x plus c. Now it have been given that the circle should pass through the points 0, a and 0, minus a. Right, now to find the equation of such circle, we know that the family of circles will be x minus 0 into x minus 0 plus y minus a into y plus a plus lambda times equation of the line, that is x equal to 0. So that is lambda into x equal to 0. So this gives me x square plus y square plus lambda x minus a square equal to 0. Now it can also be written as x plus lambda by 2 whole square plus y square equal to a square plus lambda square upon 4. So this is the equation of circle. Right, now it touches the line y equal to 2x plus c. Right, now let us say this is the circle and this is the line. So its center is minus lambda by 2 comma 0. This is the center. So equation of the line is y equal to 2x plus c. So we have radius equal to under root a square plus lambda square by 4 equal to, putting this point in this line, we will get 2 into x, that is minus lambda plus c minus 0 modulus upon under root 1 plus 4, that is root 5. Squaring both sides, we will get a square plus lambda square by 4 into 5 equal to lambda minus c whole square, that is lambda square plus c square minus 2 times lambda into c. Solving this further, we will get lambda square plus 8c lambda plus 20a square minus 4c square is equal to 0. So from here, let us say the two circles have the center as minus lambda 1 by 2 comma 0 and minus lambda 2 by 2 comma 0. So lambda 1 into lambda 2 is equal to 20a square minus 4c square. Now it has been given that the two circles cut orthogonally. For that we know the condition that 2g1 g2 plus 2 F1, F2 is equal to C1 plus C2. This is the condition. Now here the value of G1 is lambda 1 by 2 into lambda 2 by 2, and the value of F1 and F2 are 0. So this is equal to C1. Value of C1 is minus A square and C2 is also minus A square. So it can be written as minus 2A square. 2 can be cancelled on both sides. Now lambda 1 into lambda 2, that is 20A square minus 4C square is equal to minus 4A square. So dividing by 4, we will get 5A square minus C square plus A square is equal to 0. That is, from here we get that C square is equal to 6A square. So this is the required answer. So from the given options we can see that the correct answer is option number 3. Next is question number 75, which says that solution of the differential equation dy upon dx equal to y into y4 plus 1 upon 2x into y raised to the power 4 minus 1 if y of 1 is equal to 1 is. We have to solve this differential equation. So students, now here it has been given to us that dy by dx is equal to y upon 2x into y4 plus 1 upon y4 minus 1. Let us multiply in the numerator and denominator by y. So here we have y square and here we have 2xy. So this can be written as 2xy into y4 minus 1 into dy is equal to y square into y4 plus 1 into dx. That is, we have 2xy5 dy minus y6 dx is equal to y square dx plus 2xy dy. Here further let us divide on both sides by y4x square. Let us see what we get from here. We have 2xy dy minus y dx upon x square is equal to y square dx plus 2xy dy upon x square y4. Now it can be observed that this is the differentiation of y square upon x, and similarly on the right hand side we can say that it is the differentiation of 1 upon xy square. Now further, if I integrate on both sides, then we will get y square upon x plus 1 upon xy square is equal to constant. Now in the question it have been given that at x equal to 1, value of y is 1. So we get that 1 plus 1 is equal to c. That is, the value of c is 2. So we can say that y square upon x plus 1 upon xy square is equal to 2. Multiplying the whole equation by xy square, we will get y raised to the power 4 plus 1 equal to 2xy square. So from the given options we can see that the correct answer is option number